Okay, we've started it up. If anyone's online, say hello in the chat. This is going to be a free online school for science. In the chat window, please ask any questions that you want to steer the lesson. I might go at times too quickly or too slowly, and then you can just say speed up or slow down. Also, please feel free to ask questions whenever you want, and I'll just stop and explain things if I'm going too fast. First, I thought we'd start with an egg, because that's totally unrelated to what I'm going to cover, but that's also because this lesson has not really, well, it didn't really have a fixed topic in advance because I was just doing a random one for the trial. So this lesson is going to be about speed and moving. But I thought I'd start with just a quick thought on this egg right here. View the egg. The egg has got a shadow, and I'm wondering what you guys think that shadow weighs. How much does the shadow weigh? That's just the thought for the back of your minds during the lesson, but actually has nothing to do with the lesson because the lesson is on speed. Moving along to the actual lesson now. So, first question, what is speed? Everyone knows what speed is really, but sometimes it can be a bit confusing to use it in physics. So one of the ways that I think it's easy to remember what it is to think about some units. So can you think of any units for speed? And if you can, just throw them into the chat window. Okay, so kilometers per hour is one that a lot of people will see in like a car. Or another one that you'll get loads in the UK is miles per hour. And those are classic ones because you see them in the car and you see them on the road and you see all this stuff before you start learning about physics. What I want to show you guys, because I feel like this is something that often isn't taught in schools but is one of the most useful things in physics, is what the word per means. The word per means divide. A lot of your teachers will be telling you, oh, you've got to learn these equations off by heart, but actually loads of the equations are already in your minds. You already know them. It's just that you might not know how to translate them. So let's look at this one here. So miles per hour means miles divided by hours, and that's the speed. Another way of thinking about it is that miles is a measurement of what? It's a measurement of distance. And hours is a measure of what? And hours is a measurement of time. Cool. And so locked inside that unit that you already know, because everyone already knows miles per hour and kilometers per hour, locked inside that is the equation for speed. Distance divided by time. And there are loads of others that you'll find you can do that with. Speed equals distance divided by time. So let's look at this humble goose. Come back. Does anyone ever had any bad experiences with geese? Because geese can be fierce. If a goose wanders 30 meters in 10 seconds, then what speed is it waddling at? So try and work this out yourself. I'm going to show you how you'd lay this down in an exam. If this was an exam, you would want to first write the equation, which we've got here, so I'll just copy it out again. So writing the equation will often get you a whole mark if it hasn't been asked in a previous question. Speed equals distance divided by... Next, you can often get a whole mark from just writing on the next line the same thing but just plugging in the numbers. So the distance travelled is 30 meters, and you need to make sure you use all the standard units. And the time is 10 seconds. So 30 divided by 10 is 3, and because we did meters divided by seconds, what do you think the unit's going to be? Cool, meters per second, exactly, yeah. Because you're doing meters divided by seconds. Jesse wants a shout out in the chat for having got this right. Well done, Jesse. You get your shout out. When you use equations in physics, it's really important to make sure you use the standard units. So speed is measured in meters per second, and distance is measured in meters, and time is measured in seconds. I'm just gonna change this question below. Let's change that to kilometers. So same goose, and this goose is now going to waddle at 8 meters per second. How long will it take to go 64 kilometers? So think about the way that this was laid out last time. Often you'll get 1 mark for the equation, 1 mark for the working, 1 mark for the correct answer, and 1 mark for the units. So those are the 4 things you always need to lay down. So when you're writing down your own answer, lay it down in that way as well. Who has got an answer? So I'm going to start laying it out while people try and work out an answer as well. Okay, so we want to get time to be the subject of the equation because we want time as the answer. Now, because time is on the... Oh, did someone just get an answer? 8,000 seconds is the right answer. Yeah, cool. Yeah, so well done, Jesse. Let's grab time from here, and we're trying to make time the subject of this equation. Now, one of the mistakes that people make with this is they'll divide both sides by distance, and they'll end up with speed over distance equals time, and that's not right. When the thing you're trying to make the subject of the equation is on the bottom of the fraction, you've got to times by that first. So in order to make time the subject, we need to first times both sides by time. So we started with speed equals distance over time. So times both sides by time will give us speed times time equals distance. And then you can divide both sides by speed in order to get speed times time divided by speed is just time. And then distance divided by speed is going to be distance over speed. So now that you've got time as distance over speed, all you have to do is plug in the numbers from the question. In the question, this is your distance, but it's in the wrong units. So you need to convert it to the right units, which are meters. So instead of writing 64, you've got to write 64,000. And then divide by time. So the time, it's divided by speed, sorry. So the speed is 8 meters per second, and that's in the right units. So you just pop that in. So 64,000 divided by 8 is going to give you, 8,000 seconds. Cool. Now 8,000 seconds is a totally fine unit to use because seconds is the standard unit. But if you want to convert it to minutes, then you divide by 60. And if you want to convert that to hours, you divide by 60 again. Anyway, we'll leave it as 8,000 seconds for now. Okay, so next bit. This is a distance time graph, which is another one of the things that can be quite tricky in GCSE Physics. Now, before we look at the distance time graph, the key thing when you're looking at any graphs in physics is to understand what the gradient is. So I'm just going to do a quick recap on gradient, but honestly, before you start looking at any of this and like trying to say what each of the sections mean, you need to make sure you know what the gradient is. So the gradient is basically the steepness. So how steep a line is. So this line is pretty steep, and then an even steeper line would be like that. And so this even steeper line has a bigger gradient, and the shallow line has a smaller gradient. So yeah, the gradient is just the steepness, and the way that you measure it is like a lot of the time in school you start measuring it as rise over run. So you say the gradient is how much a line rises by divided by how much it runs across. So what I mean by that is this. So if we just take this section of line here, then the rise from here to here is 12, and the run from here to here is 6. And so the rise over run of this section would be, what do you think? Yeah, 2, nice. 2 would be the gradient for this section here. The other way of thinking about it would be the change in y, so this is the way you might have seen it as well. Triangle. Some schools will cover this and others won't, but this triangle means change. So the change in y, so that's this again, change in y, divided by the change in x, which again is this. So again, it's just 12 divided by 6. But the reason why this is so important is because if you look at what the y is measured in, y, the change in y is the change in the distance. The change in x is the change in the time. So what you're really doing here when you measure the gradient is you are finding the change in the distance divided by the change in the time, which is the speed, because that's the same as the equation that we were using just before. Again, I think this is something that's really useful. I know that there are loads of schools that just teach you distance time graph. Just remember that the gradient is speed, but actually it's such a useful thing when you encounter other graphs, not only in the rest of physics, because there will be other graphs like this as well, but also in life in general, just to understand that the gradient is always whatever the y-axis is divided by whatever the x-axis is, and you'll know a lot of equations that will link to that, so you'll be able to see what it is. The key idea is that for this graph here that we are looking at, the gradient, the steepness, is the speed. And now we can start to understand what the graph means. Right, so does anyone know what this first section of graph means? Just give some time for people to say what they think. So okay, if no one knows. Okay, right, let's explain it. So this first bit of graph shows a line that is the same steepness. If you imagine that you're like a person and you're at the bottom of this hill and you're walking up the hill, then it's just as steep the whole way up. So all the way that you go is the same steepness, which means the whole way is the same gradient. And that means the whole way is the same speed. So this first section here, we'll call it section 1, is a region where we have a constant speed. And we know that the speed is the gradient. So can anyone calculate the gradient for that section? We already did it before. Can anyone work out what the gradient is, so what the constant speed is for this first section, section number 1? 2, brill, yeah, we did it before. So it's 2, Fatima's just joined the chat, welcome Fatima. For this section here, the rise is 12 and the run along is 6. And so the gradient is 12 divided by 6, which is going to be 2. So there's a constant speed of 2 and the units are meters per second because it's meters divided by seconds. Okay, so let's look at the next bit. So again, imagine you're a human who's wandering across this bit. What is the steepness of this section here? We'll call it section 2. What do people think? Any ideas? So steepness is 0. Yeah, great. So this section has a steepness of 0. It's completely flat. So the gradient is 0, the steepness is 0. That means that the speed is 0. 0 meters per second. And the word that we use for this in Physics GCSE is stationary. Okay, cool. Right, now let's go on to the next section, section 3. So for section 3, I'm going to let people work this out for themselves, what they think is happening, and I'll wait for the right answer to appear in the chat window. Fanima's already answered. Okay, what's Fanima got? Fanima's gone for 7 meters per second. Okay, that's not quite right. So let's go through it again. For this section here, first, if you think about walking along it, then if you're walking down the hill, then the steepness is the same the whole time. So the gradient is the same, the steepness is the same, and that's how you know, because the gradient is the speed, that's how you know that we're at a constant speed. So you're right to have gone for a constant speed but 7 is not quite right. So how we get it is we need to think about how we calculate the gradient. So to calculate the gradient, we need to do the change in y divided by the change in x. So for this section here, the change in y is from the top down to the bottom. So the change in y is minus 12. And that minus is really important because we're going downwards, negative. And then the change in x is going to be from 13 across to 16, so that's going to be 3. You could also call this the rise. That's why I quite like the word rise for gradient, because you can see that the rise is negative because it's going downwards. So the rise is minus 12 and the run is 3. So what do we think the speed is going to be? Fanima, minus 4, spot on, that's brilliant. Yes, minus 4 meters per second. Fantastic, really good. Now let's look at this section here. So we'll call it section 4. What do people think is going on in section 4? Exactly, 0. Really good. Because it's totally flat, there's no steepness at all. That means that the speed is 0, and so we would use the word stationary again. Okay, so this final section is a bit weird. I just want people to think a little bit about what this final section might mean. We'll call it section 5. And so on this final section, you're stood here, you're heading up this hill. What do you notice as you head up the hill? As you head up the hill, it's getting steeper. So it starts off really easy to climb, and then by the time you're doing this, you basically have to have the feet of a gecko to be able to climb up it. They're developing these new gecko glove things which will allow you to like climb on, because the way that geckos stick to things, they have loads of like tiny hairs that kind of attract to one another in the same way that like atoms attract to one another with this thing called van der Waals forces, which I'll talk about in another lesson. But basically we're developing these gloves which might allow people to kind of walk on surfaces and things a bit closer to how a gecko does, which would be so cool. Anyway, That's not related. Steepness. As you climb up here, the steepness increases. So you start here and it's very shallow, and then as you get to the top, it becomes very steep. And that means the steepness is increasing. And because the steepness is increasing, the gradient is increasing. And that means that the speed is increasing. So for this whole section, what word would you use to describe what's happening in this section? Not hearing anyone coming with suggestions yet, so I'm going to drop it in. So that someone says it's hard to go faster when you're going up a hill that's steep. Because the steepness is increasing, you are accelerating. So the steepness goes up, the speed goes up. So this section here you would call acceleration. And that is everything you need to know for a distance time graph. So that's kind of the end of this lesson. Does anyone have any questions before I stop? And I will also go back to the egg for the final point. Oh, thanks Fatima for enjoying the gecko fact. If we've got no questions, then I'll just crack on with the shadow. Throw in questions as well while we're still on, just in case there's a bit more time. How much does a shadow weigh? So this is kind of getting to like really cool physics that you do later on, but basically light has this effect where it can apply force to stuff. So as light shines onto your face, it's literally like pushing you. But the pushing effect is really, really tiny. But still, the pushing effect during the daytime from the sun pushing on the surface of the earth is enough such that when you put a shadow over something instead, it kind of releases the pressure on it. It releases how heavy it seems. And so if you have a shadow the size of London, then it will reduce the kind of weight of London by about 3 human beings worth, which is pretty cool, I think. Anyway, thanks so much for coming on this AimHi Live. This one was just a trial, and so tomorrow we'll get going with doing proper lessons with more of a structure, and I'll work out like what I'm going to do. Might actually end up rerunning this one or something similar. But please let us know any comments and suggestions, because yeah, we're learning this as we go along, and we're just trying to do this for free to help people. Thanks so much for everyone who came on. So thanks to Fatima and thanks to Jessie for asking questions. And yeah, we shall see you next time, I hope. Thanks so much, everyone. Ciao.